All right, day one of lesson 56, and we are going to graph some functions. Today we're going to focus on x and the absolute value of x. So your textbook is going to use this ABS of x for some reason here. But when you take a look at the homework assignment, they actually use the absolute value symbol. So I don't know why, but they do. So we're just going to start with graphing x. We're going to talk about where is it increasing, decreasing? Does it have a minimum or a maximum? The x and y intercepts, the domain, the range, and any symmetry. And my guess is most of us won't need to use kind of that shotgun approach. I think most of us know that x is linear and it has a y-intercept at 0 and the slope is 1. So if you didn't know that, you know it now. And so I can draw that graph. And there we have it. So now as far as everything else, where is it increasing? Well, in this case, this one's always increasing. So it's increasing everywhere. We like to use that interval notation. So it would be from negative infinity to positive infinity everywhere. It's never decreasing. Now that can change, obviously, depending upon what the slope is. It doesn't have a maximum or a minimum. So no maximum. No minimum. X and Y intercepts. Now it crosses the x-axis at 0, 0. It crosses the y-axis. The y-intercept is also 0, 0. The domain. Well, I can plug any value in for x. So the domain goes from negative infinity to positive infinity. The range. Again, I can get any value. So negative infinity to positive infinity. And symmetry. So if I plug in 1, I would get 1. If I plugged in -1, I would get -1. Those are opposites. So this is an odd function, which means it is symmetric through the origin. And so you will be looking at graphing different linear functions as part of your assignment today. So you might have something like this, 3x. And all we're going to ask is you graph and then state the domain and the range. So again, if you're not sure how to graph, use the shotgun approach. Pick some values from for X, see what you get for Y. Maybe go -2, -1, 0, 1, 2. So if I plug in -2, I get 3 times -2, which is -6. If I plug in -1, I get 3 times -1, which is -3. If I plug in 0, I get 0. If I plug in 1, I get 3. If I plug in 2, I get +6. So there we go. Again, you don't have to use the shotgun approach for this one. I think you would be okay. I think, we should know how to graph that without the shotgun approach, thinking about intercepts and other things, but there's our graph. The domain, I'm just going to use the letter D. Again, we can plug in anything. -infinity to +infinity. I don't know why I put a curly bracket there. And the range also -infinity to +infinity. You could also write all real numbers. That would work. The second graph we want to look at is the absolute value of X. So again, those of you who were in intermediate algebra 2 as a 9th grader, we did a lot of work with absolute value of X. Again, we want to talk about where this is increasing, decreasing, where it has its maximum, its minimum, X and Y intercepts, domain, range, if it has any asymptotes, and symmetry. So if you remember, the absolute value function has that V shape. So it looks like that. So let's see, increasing. This one increases from 0 to infinity. And it's decreasing from -infinity to 0. Maximum, none. Minimum is at the point 0, 0. The minimum. X-intercepts. The x-intercept is the point 0, 0. Y-intercept. That's the point 0, 0. The domain. I can plug in any value for X. So the domain is -infinity to +infinity. The range here, I don't have -infinity to +infinity. The lowest value that I can get is 0 for just the absolute value of X. And it can go to +infinity. There are no asymptotes. I'm not going to worry about that. The symmetry, though, if I plug in, well, I think you can see it here, but if I plug in 1, I get 1. If I plug in -1, I also get 1. This is an even function. It is symmetric across y-axis. All right, so again, we're going to take a look at a different absolute value function and graph that. And again, we'll use the shotgun method. So for this one, f of x, absolute value of x minus 2. So will always pick values so that I get 0 in my absolute value, and then also a couple numbers on either side. So in this case, I'm going to check -2, -1, 0, 1, and 2. That's very good for my shotgun approach. If I plug in -2, I get the absolute value of -2 minus 2. Well, the absolute value of -2 is 2, minus 2 is 0. If I plug in -1, I get the absolute value of -1, which is +1, minus 2, that's -1. Absolute value of 0 is 0, and 0 minus 2 is -2. And likewise, if I plug in +1, I get +1 minus 2, which is -1. And if I plug in +2, I get 2 minus 2, which is 0. So those points graph that way. And if I then draw my graph, it should look something like that. All right. So if you need the shotgun approach, use it. If you don't, I understand that you've done these before. This is always a good fallback, though. I did not yet state the domain and the range. So let's do that. I'm not sure exactly what happened there. All right, so the domain, again, I can plug in any value for x, -infinity to infinity. Now my range changes from what it was before. Now I can go all the way to -2 and all the way up to +infinity. So there's our domain and range for our absolute value function. All right, so for your homework, on page 386, you're going to do in problem set 56A numbers 1 and 2. And in 56B, you're going to do 1, 2, 9, 10, 17, 18, 25, 26, 33, and 34. And then we will look at a couple more functions tomorrow. Have a great day.